grade 8. Let us look at 1.3 now. I want you to follow me very, very carefully here. I'll go through these things very slowly. Right. Which of the following statements is false? So we're only checking one that is false. Right. Now, this question is quite ridiculous, I know, but it is not. Right. A square is a rectangle. No. A rhombus is a kite. A trapezium is a parallelogram. A rhombus is a parallelogram. Right. They love these questions. They love them. So we need to be always ready. Go to the exam with our arms, right? Ready to fight, right? So now, what I need you to do, my strategy to approach this problem is quite different and also quite simple. As long as you know your properties. But if you don't, I'm going to go through the properties, right? So, here is my square. Here is my rectangle. They are saying a square is a rectangle. So what I need to do is to check if the square has the properties of a rectangle. Please, I'm going to repeat that because it's very important. So I've drawn these two shapes, right? Now I need to check if a square is really a rectangle. So how will I check that? I will check by seeing if the properties of this rectangle fit in a square. Why one? So let me start with a rectangle. A rectangle, all these angles, they are congruent, they are equal. This side is equal to that one, right? But they are also parallel. This side is parallel to that one, but they are also again equal. Those are properties of a rectangle. Now I'm trying to check if a square is really a rectangle. How will I do that? Check the properties of a rectangle if they fit exactly in a square, no remainder. They fit exactly. Why one? So let's go. Now I need to check if this side is equal to that one and they are also parallel. Yes, a square, this side is equal to that one and again they are parallel, right? Right. Even this one, even these two opposite sides, this side is equal to that one and again they are parallel. Yes, they are parallel. And all the angles are congruent. They are equal to 90 degrees, just as the rectangle. So this is true. A square is a rectangle. A square is almost all the other shapes beside the trapezium. A square is not a trapezium, but it is a rhombus, it is a parallelogram, it is a kite also. Yes, a square is a kite because the properties of a kite fit exactly in a square, right? So let's go. Right. My God. Let's go to the next shapes now. Let's go to rhombus. 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 Again, rhombus is almost like a square, right? All sides are equal, but only the opposite angles are equal. Not all of them are equal. No, not like a square, and it is slanted a little bit, right? Not like a square. So they are not. The angles are not equal to 90 degrees. So those are minor differences, but a rhombus almost look like a square. If you can fix it a little bit to be straight, then it will be a square. So they just slanted those sides, these two sides, and that one they had to move a little bit. You know, just for interest sake. Now, they are saying a rhombus is a kite. Let us draw a kite, my friends. I want us to also draw a kite, my dear friends. And I did do a kite before, so these two sides are equal, these angles are equal, and these two also are equal. You know, frankly, that is what we need to know. Right. So let us check. So again, I will reiterate. we are checking if a rhombus is a kite. So we taking the properties of a kite, try to fit them in a rhombus. If some of the properties do not match, then a rhombus is not a kite. Right? This is the guy, this is our target. So we use this guy to check this guy. So we use kite to check rhombus. This shape to check that other shape. So let me stop this. Right. Let us go. So what are the properties of a kite? Two pairs of adjacent sides are equal. Okay, that means adjacent means one next to the other. So this side is equal to that one. As you know, all the sides of a rhombus are equal. These two sides are adjacent as they are also equal. So the property of a kite fits exactly in a rhombus. Okay, it says that one pair of opposite sides are equal. Exactly, I can take only one pair. Even these two, they are equal, one pair. Just that a kite has more opposite angles equal, right? Do you understand? No side, I was talking about angles. So that property again fits exactly in a rhombus. So a rhombus is a kite. However, this is how you look at this. I know it's difficult when you look at the statement a trapezium is a parallelogram. If that is true, then a parallelogram is a trapezium. No, you don't think like that. This is mathematics. This is mathematics, right? You have to read in codes sometimes and try and find a way to approach that problem. I know. If you know English, you can swap the two. Like I said, if trapezium is a parallelogram, therefore a parallelogram is a trapezium. No. That is not how we do it. A square is a rectangle. Therefore, a rectangle is a square. You know? See, I know that logic, but we don't apply that logic here. Right. So let us go to C. So a trapezium, I'll draw it roughly. A trapezium doesn't have so many properties. A trapezium, all we know is that these two sides, they are parallel. So we have one pair of parallel sides. Nothing is equal unless it's a special trapezium, which is an isosceles trapezium, but we're not talking about that here. We're talking about a normal trapezium with one pair of parallel sides. So they are saying a trapezium is a parallelogram. Right. You can already see, or you can already visualize how will that be any possible. Right. So, I'm going to start with simple properties of a parallelogram that will never fit in a trapezium. Trapezium is quite different from the other shapes. They are very interesting, but a trapezium is a lone wolf. It fights its own battle alone somewhere, because these other shapes, they have a relationship, especially a kite and a rhombus, they have a relationship. A square and a rectangle, a relationship, a square and a rhombus. But a trapezium, you must always look at it first. If you see it in the options, try to look at that first. There must be something false there. Not always, but try and check. Right. So the properties of a parallelogram: opposite angles, they are equal. Not all of them, but only the opposite. So two pairs of opposite angles, they are equal. Again, two pairs of opposite sides are equal, and parallel, equal and parallel, right? You know those properties, right? Okay, so opposite angles equal. That alone does not fit in the description or in the properties of a trapezium. So our C is the one which is false. So we have to choose C as our option, right? I don't. So do it on your own. The D, do it the same way. Check the properties. If the parallelogram properties fit in a rhombus, you see that they fit exactly, right? I did draw the parallelogram for you here. Just check if they fit in a rhombus. Here is a rhombus. Check these two. That is your homework. Check if these two, if the properties of this guy fits in this guy. Right. Thank you. Oh no, we're not done. Oh my god. We're not done. Right, let us go to 1.4. 1.4. So what are they talking about? Which of the following, which of the statements is not a property of a rectangle? Now, these two things are very important. Not. Which property is not? Diagonals. They are talking more about a diagonal and they are talking more of a rectangle. So, they are talking about these things here. So, these lines in pink, right? Those are diagonal lines, right? That cut between the vertices, not of vertices of, come on, go back, say, adjacent side, but of, they cut through these vertices, right, of opposite angles. So they cut through those angles. So these are diagonals. These are diagonals in pink. Now, these diagonals, yes, they are equal. That is what I need you to know. They are equal, right? You can measure them, you can test, try a 3x6 rectangle and draw diagonals and try to see if they're equal. Yes, they are equal. You need to know that they are equal. These diagonals bisect. Now I want us to talk about bisecting. Bisecting means wherever they meet these lines, let's talk about this one. This one is equal to that one. The moment they meet, and this line from here to there, they divide into two equal halves. This line is equal to that one. Even this one from here to here is equal to there. So that is what they mean by bisect. So we know what are diagonal lines. We know now what is bisecting, right? Beside each other at 90. So what they are saying, bisecting each other at 90, that means this is 90 degrees. It's ridiculous. So our option here is B, because they do not bisect each other at 90 degrees. So that is wrong. So they do bisect each other. Yes, I did say that. The opposite sides are equal. As we all know, the opposite side of a rectangle, they are equal. Right. So this question was very simple. All you need to know, go and check what diagonals of a rectangle and see the properties, write them down, because you know they ask questions on that. Now we're gonna move to 1.5 next. So until then.